This is the first class for the class 10 students, those who will be appearing for the ICSE in the year 2021. We have started these classes for your benefit so that sitting at home, we can reach you and help you in your preparation for the board exams. For this, we will be conducting classes for all the major subjects, the Group 1 and the Group 2 subjects. And most importantly, today is the first class in a series of classes that will be conducted on the various subjects of the ICSE, and we will be starting with literature in English. You know you have 3 texts in literature in English. Out of the 3 texts, I will be starting with the poems first because they are smaller units and can be finished within the stipulated time allotted. Then we will move on to the others. Now, as far as the poems are concerned, you know very well that you have 10 poems in your syllabus. Out of these 10 poems, 6 have already come in ICSE in the year 2020 and in the year 2019. So we are left with 4 poems which are still untouched in ICSE. So first we will pick up the untouched poems because they are the most probable as far as 2021 is concerned. Out of the 4 untouched poems, the first poem that we will pick up today is Daffodils by William Wordsworth. Now, before I begin with this poem, I will have to give you a small and a brief background to this poem. We will discuss Wordsworth's philosophy and attitude towards poetry. Then only you will be able to understand the poem Daffodils. First of all, let me tell you, when Wordsworth was passing by a lake called the Ullswater Lake, on the banks of this lake, he saw a field full of yellow-colored daffodil flowers. This experience of seeing the daffodils on the banks of Lake Ullswater became the basis and the foundation for writing this poem, Daffodils. Secondly, why did he write about the daffodils? If you have to understand this, then you will have to understand Wordsworth's philosophy and his attitude towards Mother Nature. Let me tell you, Wordsworth was a romantic poet. Romantic poetry flourished towards the end of the 18th century and continued in the first quarter of the 19th century. And William Wordsworth was a pioneer in romantic poetry. Now the question arises, what is romanticism? If you understand what is romanticism, then you will understand the poem Daffodils. Romanticism simply means love for Mother Nature. For Wordsworth, every object in Mother Nature was not only pretty, wonderful, and beautiful, they were also a source of joy and happiness. The most important point is, Wordsworth considered every object in Mother Nature to be living. Even a stone, a pebble in his eyes was a living object and therefore a source of joy and happiness. So you see, romanticism is love for Mother Nature. An object in Mother Nature is a source of joy and happiness. That, in brief, is romanticism. Now, what is its significance or effect in our life? According to Wordsworth, An object in Mother Nature is not only a source of joy and happiness, the beauty of this product is, or beauty of this object is, later in your life, when you remember that object, when you imagine about that object which you had seen many years back, your loneliness goes, your sadness goes, your sorrow goes, and the imagination and the memory of that beautiful object fills your heart with joy and happiness many years after having seen that object. Remember, Wordsworth had said that a thing of beauty is a joy forever. Mark the word forever. It's not that you look at an object, it is beautiful, you appreciate it, you like it, you love it, and then you forget about it. No. For Wordsworth, a thing of beauty is a joy forever, because even the memory of that object many years later gives you joy and happiness. This philosophy will be elucidated in the last stanza of the poem. Now, before I begin with the poem, let me tell you one thing. When you are doing Wordsworth, you will have to be very careful with the figures of speech, because romantic poetry is filled with figures of speech. And the poem begins with a figure of speech. As I was telling you, that Wordsworth was walking along the valleys and the hills on the banks of the river Lake Ullswater, when he saw the beautiful yellow-colored daffodils. He compares his own walking movement to the movement of a cloud in the sky. Look at the first line of the poem. I wandered lonely as a cloud that floats on high over vales and hills. Just as Wordsworth was walking aimlessly, moving around aimlessly on the banks of Lake Ullswater, he is comparing his movement, his aimless walk, to the aimless movement of a speck of cloud in the sky, moving from one place to the other. And as the cloud moves across the sky, it moves over valleys and hills, just as Wordsworth himself was moving along the valleys and the hills. That is why I have pointed it out. Wandered lonely as a cloud. Who was wandering lonely as a cloud? Wordsworth was moving aimlessly as a cloud, because a cloud also moves aimlessly across the sky. Now you will see I have underlined the word as. Whenever two things are compared with the word as or with the word like, you have a figure of speech which is called a simile. S-I-M-I-L-E. When two objects are compared, either using the word as or using the word like, it's called a simile. This is an example of a simile. Here, the aimless wandering of the poet is compared to the aimless movement and the floating of the clouds in the sky over the valleys and the hills. So please remember, your first figure of speech is the simile in the first line of the poem. When all at once I saw a crowd, a host of golden daffodils. As the poet was moving or ambling aimlessly along the banks of the lake, suddenly, all at once means suddenly, he saw a crowd, a host of golden daffodils. Golden because daffodils are yellow in color. Now look at the two words, crowd and host. It refers to the fact that he had seen plenty of daffodils, innumerable daffodils. He could not count how many daffodils were blooming on the banks of Lake Ullswater. Beside the lake, where did he see these daffodils blooming? He had seen it beside or by the side of the lake. Beneath the trees, imagine the bank was also filled with trees, but underneath those trees also the daffodils were blooming. That means not even a piece on the field or the ground was left out where the daffodils had not been growing. Now come to the last line of the poem. Fluttering and dancing in the breeze. Obviously, it is a reference to the daffodils. As the gentle breeze was blowing, along with the breeze, the daffodil flowers were swaying and moving to and fro from side to side. In the eyes of the romantic Wordsworth, the swaying movement of the daffodils was like the daffodils were dancing like human beings, expressing joy and happiness. Now see, a flower cannot dance. A flower may be biologically a living object, but technically it is a non-living object. It cannot do anything on its own. But here, the flowers are said to be dancing with joy and happiness. That means the flowers have been presented in this line as if they are living object. Please note, when a living object is presented in a poem or a story or a drama, it's not a problem. But when a non-living object or an abstract thing or an abstract idea is presented as living, like if I say, pride said. Now, pride cannot speak. But here, pride has been presented as something living, as if speaking. When non-living object, abstract ideas are presented as living, you have a figure of speech called personification. So here, the daffodil flowers have been personified because they are dancing with joy, just like human beings dance with joy. Okay? Now again, when we begin the second stanza, you will see the second stanza again begins with a simile. What are the lines? Continuous as the stars that shine and twinkle on the Milky Way. My dear children, when you look at the clear sky in the evening or at night, you see millions of stars shining and twinkling in the sky. Note the word or the number, millions. In the eyes of Wordsworth, the daffodils that were blooming by the side of the lake, they were millions in numbers, like the number of stars that twinkle and shine in the sky. So, the millions of twinkling and shining stars in the sky, which is the Milky Way, is compared to the millions of daffodils he could see blooming on the bank of Ullswater Lake. So here again, you have a simile. Continuous as, again see, the word as has been used for this simile. The stars that shine and twinkle on the Milky Way. The number of daffodils blooming on the bank is as plenty and innumerable as the number of stars twinkling and shining in the sky. Now see, they stretched in never-ending line along the margin of a bay. So many daffodils were there that the fields where the daffodils were growing seemed never to come to an end. And they stretched on the banks of the Ulswater Lake to infinity, as if the fields of daffodils would never come to an end. 10,000 saw I at a glance. Now this 10,000 is important. At one look, the poet says he had seen 10,000 daffodils. Now at one look, it is not possible to see 10,000 daffodils. Obviously, he is exaggerating. The fact is, he saw many hundreds. But he is saying he saw 10,000. He is exaggerating the fact. He is saying more than what is the fact. That is why this 10,000 again, when you exaggerate, say something more than the fact, it is also a figure of speech. It is called hyperbole. So this 10,000 is an exaggeration. It is an example of a hyperbole. He saw many, plenty, but not exactly 10,000. That is the point. Tossing their heads in sprightly dance. Again, this line is similar to the last line of the first stanza. Here again it is said that the daffodils were tossing from side to side in an energetic dance. Sprightly means energetic. Again, what is dancing? Daffodils. Why are they dancing? Because they are very happy and joyful. Again you see, daffodils are dancing in an energetic dance. Again, here the daffodils have been compared to human beings dancing with joy. Again, an example of personification, because here the daffodils have been presented as if they are living. The waves beside them danced. Where were the daffodils growing or blooming? By the side of the lake. Imagine, on the lake also, the waves of the water were moving. The poet is saying as if the waves were also dancing with joy. Again, see, the waves beside them danced. The them obviously are the daffodils. Again, waves are non-living objects which were seeming to dance. That means even the waves have been personified. But they outdid the sparkling waves in glee. Outdid means did far better. And glee meaning happiness. Now the point is that when the poet was looking at the dancing waves and when he was looking at the dancing daffodils, the poet felt that the daffodils were dancing far better than the waves in the lake. The daffodils were expressing more joy and happiness more than the waves were expressing happiness by dancing in the lake. So the focus is on the daffodils, not on the waves. A poet could not but be gay in such a jocund company. Now, gay meaning happy, jocund also means happy. Obviously, if you are in the company of people who are happy, you also feel happy. Similarly, when the poet was in the company of the happy daffodils, the joyful daffodils, even the poet himself was also feeling happy. The happiness of the daffodils was reflected on the poet, and the poet too was also feeling happy. I gazed and gazed, but little thought what wealth the show to me had brought. You know, the poet was gazing, meaning looking, at the daffodils continuously. He was enjoying the moment. He was enjoying the beauty of the daffodils. He was feeling happy and joyful. He was enjoying the pleasure of seeing the daffodils. But at that moment, he did not realize one thing. He did not realize that this is not an experience which will last for him a few hours. He had gained an experience. He did not know that this experience will last for him throughout his life. Now listen to this wealth. This word wealth here means experience. Now, the poet was enjoying looking at the daffodils. He was feeling happy and joyful looking at the daffodils. But one thing he did not realize, that this happiness and joy will not come to an end once he leaves this place. This happiness and joy will remain with him forever. The point is, many years later, when he will be sitting at home and remembering the beauty of the daffodils, when he will imagine the picture of the dancing daffodils which he had seen, again his heart will be filled with happiness. A thing of beauty is a joy forever. Meaning, what you see now, you enjoy it now, but that enjoyment lives with you throughout your life. So this is a lifetime experience which has filled him with joy and happiness, which will last with him forever. And this is the most important point about romanticism, which he explains very clearly in the last stanza of the poem. See, for oft when on my couch I lie, in vacant or in pensive mood, they flash upon that inward eye, which is the bliss of solitude. Many years later, imagine the poet Wordsworth is sitting on a couch. Couch is a sofa. His mind is blank, vacant. His mind is empty. He is sad. He is sorrowful. He is in a thoughtful mood. At that moment, they flash upon that inward eye. Here, they means the daffodils. And inward eye means mind, memory, or imagination. So, sitting on the sofa in a sad, sorrowful, thoughtful, pensive mood, the image of the beautiful daffodils comes back to his mind. Am I clear? And which is the bliss of solitude. The moment the picture of the beautiful, pretty, dancing, happy, joyful daffodils come back to the mind of the poet, his sorrow vanishes, his emptiness vanishes, his sadness vanishes, and his heart is filled with happiness, joy, and pleasure. And that is what he says. And then my heart with pleasure fills and dances with the daffodils. The point is, the moment the poet is reminded of the image of the daffodils, the moment he imagines the picture of the dancing daffodils, the sadness, the sorrow, the loneliness simply vanish from the heart of the poet, and the poet's heart is filled with joy and happiness, and in his imagination he starts dancing with the beautiful, pretty, happy, pleasurable, joyful daffodils. That is how the poem ends. And the last stanza of the poem, as I told you, explains what actually romanticism is. I told you, romanticism is love for Mother Nature. But romanticism does not mean you see a flower, you appreciate it, and after 5 minutes, once you leave that garden, you forget about that flower. No. Romanticism means what you have seen remains with you throughout your life. And the pleasure of having seen that flower in the garden comes back to your mind many years later. And the moment you are reminded of that beautiful rose that you had seen in somebody's garden, fills you with joy and happiness. and removes your sorrow, sadness, and loneliness. That is romanticism. So, the central idea, the theme, the message, the moral of this poem is a thing of beauty is a joy forever. Meaning, when you look at a beautiful object in Mother Nature, it fills your heart with joy, happiness, and pleasure. And that joy, happiness, and pleasure is not temporary. It stays with you forever. And in the future, in your life, whenever you are in a sad, pensive, thoughtful, sorrowful mind, you are reminded of the beautiful objects that you had seen in Mother Nature, and the memory of those beautiful objects fill your heart with joy and happiness and removes all the loneliness, sorrow, or sadness. That is the poem. But be careful with the figures of speech. Mainly, you have simile, you have personification, and you have example of hyperbole. Be very careful with these figures of speech, because figures of speech are now asked as questions in ICSE. This is Daffodils. In the next class, we will do another untouched poem in ICSE, and a very important one, The Cold Within. Thank you. Stay home, stay safe.
Hello everyone. Today I am going to teach you trigonometry. In class 9 you have done the basic things in trigonometry, the meaning of trigonometry, trigonometric ratio of standard angle, trigonometric ratio of complementary angle, and the main mantras of trigonometry, that is, some people have curly brown hair turns permanently black. So here in class 10 you have to learn how to prove trigonometric expression by using identities, and these are the important identities in trigonometry. Number 1, sin square theta plus cos square theta equals to 1. From here you can derive two identities. Sin square theta equals to 1 minus cos square theta, and cos square theta equals to 1 minus sin square theta. Similarly, second identity, sec square theta minus tan square theta equals to 1, sec square theta equals to 1 plus tan square theta, and tan square theta equals to sec square theta minus 1. And the third identity is cosec square theta minus cot square theta equals to 1, cosec square theta equals to 1 plus cot square theta, and cot square theta equals to cosec square theta minus 1. Now, this from number 4 onwards, you have done in class 9 also, tan theta equals to sin theta by cos theta, cot theta equals to cos theta by sin theta, cosec theta equals to 1 by sin theta, or sin theta equals to 1 by cosec theta, sec theta equals to 1 by cos theta, same goes here, tan theta equals to 1 by cot theta. Now let us do few questions. Prove the following identities. Number 1, 1 minus sin square theta into sec square theta equals to 1. Now, if you look at this question properly, your question is divided into two groups. This is left hand side and this is right hand side. Here, you have to take left hand side and you have to prove right hand side by using that identities. Now, 1 minus sin square theta. Now, what is the formula for 1 minus sin square theta? 1 minus sin square theta means cos square theta. So, instead of 1 minus sin square theta, you write cos square theta into, now, sec square theta. Sec square theta equals to 1 plus tan square theta. sec square theta equals to 1 by cos theta. Now in this case you have to apply sec theta equals to 1 by cos theta because right hand side is 1. So here sec square theta means 1 by cos square theta. Cancel these two, hence proved. Similarly, question number 2. Question number 2, 1 minus cos square theta into sec square theta equals to tan square theta. Similarly, now find out the formula for 1 minus cos square theta. Now 1 minus cos square theta means again sin square theta. Sin square theta into sec square theta means again 1 by cos square theta. Now sin square theta into 1 is sin square theta divided by cos square theta. Now if sin theta by cos theta is tan theta, similarly sin square theta by cos square theta is also tan square theta. So sin square theta by cos square theta is tan square theta, hence proved. Now question number 3. Question number 3, 1 plus tan square theta into 1 minus sin theta into 1 plus sin theta equals to 1. Now what do you mean by 1 plus tan square theta? Now find out from there. 1 plus tan square theta means sec square theta. 1 plus tan square theta means sec square theta into, now there is no formula for 1 minus sin theta. Had it been 1 minus sin square theta, then it is cos square theta. Now 1 minus sin theta, 1 plus sin theta, this is a minus b, a plus b, and the formula for a minus b and a plus b is a square minus b square. It means 1 minus sin square theta. Now again sec square theta means you write 1 by cos square theta into 1 minus sin square theta means cos square theta. Cancel these two, answer is 1, hence proved. Number 4, 1 plus tan a whole square into 1 minus tan a whole square equals to 2 sec square a. Here your left hand side is 1 plus tan a whole square, 1 minus tan a whole square, and your right hand side is 2 sec square a. This is ICSE 2005 question. Now here you have to apply a plus b whole square. Now what is the formula for a plus b whole square? A square plus b square plus 2ab means a square, 1 square is 1 only, a square plus b square plus 2ab, you can use bracket, so this is plus, plus again a square plus b square minus 2ab. Now this minus 2 tan a and this plus 2 tan a will get cancelled. Now what is the formula for 1 plus tan square a? 1 plus tan square is sec square a. Sec square a plus again 1 plus tan square a means sec square a. So sec square a plus sec square a is 2 sec square a, hence proved. Now let's do next question. Question number 5, cosec a minus sin a into sec a minus cos a into sec square a equals to tan a. Now I think this is ICSE 2011 question. Here left hand side is cosec a minus sin a into sec a minus cos a into sec square a, and right hand side is tan a. Now again you have to prove this tan a. Now for that you have to take left hand side. Now again what do you mean by cosec a? Find out from there. Cosec means 1 by sine A minus sine A into, again sec means 1 by cos A minus cos A into sec square means use 1 by cos square A. After that, take out LCM. Obviously, LCM is sine A. Now, 1 minus sine square A into LCM is cos A. 1 minus cos square A into 1 by cos square A. Now, 1 minus sine square A means cos square A divided by sine A into 1 minus cos square A means sine square A divided by cos A into 1 by cos square A. Now, cos square cancel, sine is cancelled because there is sine square. Therefore, what is left? Sine A divided by cos A. Now, from the formula, sine A divided by cos A is tan A, hence proved. Now, next question. This is number 6. Sin theta into tan theta divided by 1 minus cos theta equals to 1 plus sec theta. Again, your left hand side is sin theta into tan theta divided by 1 minus cos theta, and your right hand side is 1 plus cos theta. Again, take left hand side, you have to prove right hand side. Now, sin theta into, what do you mean by tan theta? Tan theta means, we know it is sin theta by cos theta divided by 1 minus cos theta. After that, sin theta into sin theta is sin square theta divided by cos theta into, this is called reciprocal, 1 divided by 1 minus cos theta. Now, again, what do you mean by sin square theta? Find out from there. Sin square theta means 1 minus cos square theta divided by cos theta into 1 minus cos theta. Now, 1 minus cos square theta means you can think a square minus b square, which is a plus b, a minus b. So you can write 1 plus cos theta into 1 minus cos theta divided by cos theta 1 minus cos theta. So that 1 minus cos theta, 1 minus cos theta will get cancelled. Now, what is left? 1 plus cos theta divided by cos theta. Now, this cos theta is for both 1 as well as cos theta. So you have to write 1 divided by cos theta plus cos theta by cos theta. So 1 by cos theta means 1 by cos theta means sec theta. This and this cancel, plus 1. Now, next question. Okay, today's last question. Now, cos theta divided by 1 plus sin theta plus, now tan theta means, find out from there, tan theta means sin theta by cos theta. Now, take out LCM. LCM means denominator everything. What is denominator? 1 plus sin theta into cos theta. Now 1 plus sin theta will get cancelled. Now cos theta into cos theta is cos square theta plus cos theta will get cancelled. Now sin theta into 1 plus sin theta. Sin theta into 1 plus sin theta. Now remove the bracket. Cos square theta plus sin theta plus sin theta into cos theta is sin theta cos theta divided by 1 plus Sine theta. Sine theta 1 is sine theta. Sine theta into sine theta is sine square theta. Sine square theta divided by 1 plus sine theta into cos theta. Now, cos square theta plus sine square theta or sine square theta plus cos square theta is 1. 1 plus sine theta divided by, what is the denominator? 1 plus sine theta into cos theta. It means 1 plus sine theta, 1 plus sine theta will get cancelled. So what is left? 1 by cos theta, and 1 by cos theta means what? Sec theta. Hence, proved. Okay, this was for today. Thank you very much. I hope you have understood. See you soon in next class.
Good afternoon, students. I'm here to teach you about chemistry. Okay, and this is for your ICSE syllabus of class 10 for the board exam. But in this lockdown right now, I'm going to teach you first about the basic concept of chemistry, which will help to build your concept. As you know, okay, to make a building, foundation has to be good. Similarly, okay, to learn chemistry, you have to have a good foundation. So for that reason, I'm going to teach you some basic fundamental part of chemistry today. And in my upcoming classes, I'm going to teach you according to the syllabus wise. So let us see now. If you see out here, students, I made a small part out here. The basic concept in chemistry, okay, lies in this 4 parts. And the first one is you need to know about elements. Number 2, you need to know about atomic number, what is mass number. Number 3, you need to know about is valency. Number 4, the formula. So what if you remember all these 4? If you remember these four, then you'll come to know about how to make a correct chemical equation. And as you know, without equation, chemistry is incomplete, because we consider chemical equation as the soul of chemistry. So first, let us learn about element. What is element? Okay. Now there are 2 parts. In which way you want to learn, that depends. Okay. I think most of you have watched the movie called 3 Idiots. So there are 2 characters in that movie. One is your Rancho, the other is Chatur. Now you want to learn in Chatur style or Rancho style, it's up to you. So out here I like to give you the definition first for element. Element is regarded as a pure substance which is made up of one kind of element, atom. Okay? But you can even consider ourselves as one of the element, though we are a living body. Okay? We can consider as an element because we vary from person to person. The character, the physical look, it differs. So you can consider our look as a physical property, and the behavior of us can be regarded as a chemical property. Similarly, elements are of different kinds. Okay, they have different physical property and different chemical property. So here I'm trying to interrelate these 2. So I'm comparing the physical look of a person as a physical property and a character of a person as a chemical property. So for that reason, I always say there are 4 kinds of elements. Okay, those are metal, non-metal, metalloid, and noble gas, which I usually consider by another name as good person, bad person, the mixture of both, and Mr. Lonely. So usually I called element as metal as good person, non-metal as the bad person, having the character of both I consider as metalloid, and noble gas I usually call Mr. Lonely. Now let us see the reason why I call so. So usually we call those elements as metal which has either 1 or 2 or 3 electrons in the outermost shell, which is also known by the name valence shell, the last shell. Okay, so if they have 1, 2, 3 electron in the outermost shell, those elements are called metal. And if they have 4 or 5 or 6 or 7 electrons in the outermost shell, we call them as non-metal. But with the help of configuration, we cannot isolate metalloids, which I'll explain you later. And noble gas are those elements which have stable electronic configuration, that is duplet or octet. Duplet means to have 2 electrons in the first shell only, and octet means to have 8 electrons in the last shell. And both of them are called noble gases. So with the help of configuration, we can easily isolate metal, non-metal, and noble gas. But we cannot do so for metalloid. Reason I'll let you later. So to remember, from now on, I always consider metal as good person, non-metal as the bad, mixture of both as the metalloid, and mixture only as noble gas. Okay, why I call it good person? As you know, the good persons, they usually donate money to the charity, and we consider they are generous and they have big heart. Similarly, metal also has a big atomic size, and here I'm trying to compare the heart of a good person with the size of the metal. So do remember, metal has bigger atomic size, just like a good person has big heart. Whereas non-metal, I consider as a cunning person. So therefore, we consider they have small heart. So similarly, non-metal have small size. Clear? Now, why metal lose electron? Reason is, metal wants to become stable, okay, by losing electron. So usually they have 1, 2, 3 electron in the outermost shell. So they lose either 1 or 2 or 3 electron to become octet or duplet. Whereas non-metal have 4, 5, 6, 7 in the outermost shell. They try to gain electron in order to become octet or duplet. That is stable electronic configuration. So just like good person, they donate money to the charity. Our metal, they donate electron to the other elements. Non-metals, I consider bad person. The way they all snatch money from others, even they snatch electron from other elements. So now to explain more about this, we need to understand the term called atomic number. Just now I explained you about elements. Now we go to the atomic number and the mass number. You can see out here, I have given the symbol of sodium, which is Na, and the two number has been shown out here. One is 11, one is 23. And many students again are confused in these two numbers, whether to write up, down, okay, like that. So look out here, you can write 11 anywhere you like, whether down or up. Similarly, 23 you can write whether up or down, it doesn't matter. You can write in whichever is comfortable for you. But do remember, in these two numbers, whichever is the smallest number is regarded as atomic number, which actually denotes the number of electron present in the shell of an atom or the number of proton present in the nucleus. And this number is very important to us. It's the one foundation, main foundation of chemistry, which helps you to determine the electronic configuration of the elements. As a result, you come to know the outermost electron, how many are present in them. With the help of that, you come to know about the type of element, whether it's metal, non-metal, or noble gas. Because if they have 1, 2, 3, we call them metal. 4, 5, 6, 7, we call them non-metal. And if there's duplet or octet configuration, we call them noble gas. So from there, we can determine their valency. And from valency, we can find formula. And from formula, we can make chemical equation. Means we are going to meet the soul of chemistry. The higher number in these two is regarded as mass number. Okay, nowadays, we even call it by the name atomic mass or atomic weight. The higher number. It has 3 names. Out of which, now in 10, we mostly use these two names rather than mass number. So which name we are going to use now? For that, atomic mass or atomic weight. Now many students has confusion here. Sir, mass and weight are not same according to physics. It's true because the formula is like this. Weight is equals to mass into acceleration due to gravity. But in chemistry, we don't discuss about gravity. So just remove it out. So therefore, in chemistry, we consider weight and mass as same. So therefore, mass can be replaced with the word weight in chemistry. So therefore, this number is known as atomic mass or atomic weight. And if you know this number, it's going to help you to find the molecular mass of a compound, which is required in the calculation part of chemistry. So this number is required for the reaction, soul of chemistry. This is required for calculation base in chemistry. Now, I like to explain you further about atomic number. You can see I have made some elements here from 1 to 20. It is in your syllabus. You need to learn it by heart. Okay, so you need to remember the atomic number of the element from 1 to 20. That is from hydrogen till calcium. You have to remember these numbers by heart from 1 to 20. Now, what is the advantage you're going to get if you know these numbers? So first of all, I like to go with sodium. You can see sodium symbol is Na, atomic number is 11. With the help of this atomic number, you can distribute the electron in the cell. So if you distribute 11, it will be 2, 8, 1. And as you see, it has 1 electron in the outermost shell. We consider it as metal. And earlier I said you metal are bad or good person? Good. So they usually give. So how many it can give to make it happy? Happy means to become stable. So how many it can give to become stable? 1. If it gives 1 electron, it becomes octet. So it can give how many electron? 1. So the valency is 1 and giving is a good quality. So we represent by the symbol plus. So do remember metals are electropositive because they have positive valency. Similarly, magnesium symbol is Mg and the atomic number is 12. So the configuration becomes 2, 8, 2. So again, if you see it has 2 electrons in the outermost shell, so it is a metal and we consider it as a good person. Again, it can lose electron to become octet. So how many it can lose? 2. If it loses 2 electron, it also becomes octet. Therefore, its valency is 2. And giving is a good quality, so we represent by the sign plus. Now, aluminum atomic number is 13, so the configuration is 2, 8, 3. Again, it has 3 in the outermost shell. And 3 in the outermost shell is also regarded as a metal. So therefore, it is a good person, so it is going to give electron to others. So how many it can give to become octet? 3. If it gives 3 electron, again it becomes octet. Therefore, its valency is 3 and giving is good quality, we represent by the sign plus. So from now on, do remember metal valency will be always positive. Now we go to another example. You can see nitrogen atomic number is 7, oxygen atomic number is 8 and the fluorine is 9, chlorine is 17. So again, if you make the electronic configuration, EC means electronic configuration, it becomes 2, 5 for nitrogen, 8 means 2, 6, fluorine 2, 7 and for chlorine it becomes 2, 8, 7. So since it has 5 electrons in the outermost shell, now what is going to happen here? 5, 6, 7 is called what? Non-metal. So they are bad person. Now how they become happy, stable, octet? Bad person by gaining. Now tell me, it has already 5 out here, isn't it? So how many it can gain so that it can make 8 out here? Already 5 it has. So it can get 3 more to make it 8. So it can gain 3. And gaining is a bad quality. To snatch from others is a bad quality. So we represent by the sign minus. So the valency of non-metal will be in negative figures. Now see oxygen case. It has again 6 electron. So to become octet, it's a non-metal. So to become octet, it requires 2 electron. So it snatches 2 electron from other elements. So to make it octet, so its valency is 2. And taking its bad quality, we represent by the sign minus. Similarly, fluorine has 7. So to become octet, it requires one more electron. So its valency is 1 and again it gains from others, so we write by the negative sign, so its valency is minus 1. Chlorine has 7. So it can also gain 1 electron to become octet being a non-metal, therefore its valency is minus 1. And now do remember, metal valency will be in positive figures, non-metal valency will be in negative figures. Now, as I said you earlier, metalloid, I'm going to explain you later on, so now the time has come for that. Do remember, we can identify metal, non-metal and noble gas through electronic configuration, not the metalloid. Okay? Now you can see out here, boron atomic number is 5. So the configuration becomes 2, 3. Silicon 14, you can see from here. So the configuration becomes 2, 8, 4. So boron has 3 electrons in the outermost shell. As per that definition, it seems to be metal. And silicon has 4. As per the definition, it seems to be non-metal. But dear students, do remember, both of them are metalloid. So some metal behaves like metalloid, even some non-metal behaves like a metalloid. So metalloid cannot be identified through electronic configuration. So you need to remember some example of metalloid by heart. And 2 examples of metalloid I have shown you out here. One is boron, one is silicon. Boron symbol B, silicon is Si, and both of them are metalloids. So now if you see out here, students, I have written one word for noble gas, Mr. Lonely. Why? Because I explain you why we call metal as good person, non-metal as bad, and those who have the property of both, we call them metalloid. And do remember, we mostly in this earth are metalloids because we have some good quality, we may have some bad quality, so I consider myself as a metalloid. Now let us see why I call noble gas as Mr. Lonely. Now tell me, you can see out here why they are giving electrons to become octet, stable, duplet, stable. Why they are gaining? To become octet, to become stable. But in case of noble gas, they are already octet and duplet. They have already stable electronic configuration, that is octet and duplet. So they neither lose electron like metals, they neither gain electrons like metals, nor they share. So the person of that nature remains alone in life. Therefore, I called them as lonely persons. Okay, and I regard them as Mr. Lonely, and Mr. Lonely means they remain in monoatomic form. Monoatomic means single. For example, when you write down the formula of oxygen gas, we write O2. Nitrogen gas, we write N2. Hydrogen gas, we write H2. But for helium gas, we simply write He. Symbol of helium is He, so we write only He, not He2. Why not 2? Because it is stable and it does not lose, gain or share electrons, so therefore it remains in single form, and single means monoatomic form. Therefore monoatomic means I call it by the name Mr. Lonely. So this much is all about atomic number. Now we go to the significance of mass number. Mass number is also known by the name atomic mass or atomic weight. And mass and weight is same in chemistry, I have already explained you. Now what is the advantage of this? If you know this number, it's going to help you to calculate molecular mass or molecular weight. With the help of that, you can do the calculation based in chemistry. Now let us see what is this molecular mass. So before we know about molecular mass, you need to remember what is atomic mass or atomic weight of some elements I have given you out here. So do remember from now on, atomic weight or atomic mass of carbon is 12, and hydrogen is 1, and oxygen is 16, and sulfur is 32. There are many other elements which has different atomic mass. I have not shown you here, but this will give you an idea just to calculate molecular mass. Now let us see how to calculate molecular mass. Do remember, when we are in trouble, we remember mother. Okay, in Hindi we call it Ma. So I call it, you can see out here, I have written here M-A-A means what? Ma. Actually, the full form for me for this is, this M stands for molecular weight or molecular mass. This A stands for atomic weight or atomic mass. And this A stands for atomicity. And in between dot means multiplication sign. So what is the formula for molecular weight to calculate? It's Ma formula. Means molecular weight is equals to atomic weight into atomicity. Now I have already explained you that you need to remember this number value for atomic weight of different elements. Now I am going to teach you how to calculate molecular weight. But before we calculate molecular weight, you should know what does atomicity means. So here is atomicity now. First I will explain you about atomicity. This number you have to remember. So by multiplying these two we get molecular weight. Now let us see what is atomicity. Okay, I have written here O2. I think most of you have seen this O2 in the jersey of Arsenal. Okay, if you have football lovers. So now look out here, it's O2 out here. What is this 2 stands for? 2 stands for number of atoms, because inside this there are 2 atoms of oxygen. And oxygen is one of the element, so I have not written the particular name out here. In general, we call O as an element. So this 2 signifies number of atom, whose of one of the element, where inside a molecule, because O2 as a whole is a molecule. So if you combine these 3 words, you get the definition of it. So what is atomicity? It is the number of atoms of an element present inside a molecule. So always don't try to mug the definitions. Try to formulate it. Okay, so if you join these 3 sentences, you're going to get the definition of atomicity. So what is atomicity? It is the number of atoms of an element, that is oxygen in this case, present in a molecule. So in a very simple way, you can remember atomicity means hanging number. Whatever number is hanging in the formula, that is the atomicity. You can see out here, O2. What is hanging? 2. So therefore, it is the atomic number of atomicity of oxygen. Nitrogen atomicity is again 2, hydrogen 2, and helium how much is here? No number means it is 1. So the atomicity of helium is 1. And in chemistry, 1 means mono. Therefore, I have written here all noble gases are monoatomic. Single, so Mr. Lonely they are. Okay. So now do remember atomicity means the number which is hanging in the formula. In simple words. Now I am going to teach you how to calculate the molecular mass or molecular weight of some of the compounds. And do remember mass and weight is same. Okay, let us calculate the molecular mass of glucose first. For that reason, you need to remember the formula first. So I think everyone knows of the formula of glucose, that is C6H12O6. Those who don't know, now start remembering it. Everyone calls glucose, isn't it, in day-to-day life? If you also call glucose, you will never ever remember the formula of glucose. From now on, if you go to the market to buy glucose, don't ask for glucose. Ask for C6H12O6. In that way, when you use it in day-to-day life, you're going to remember the formulas. Okay, now the glucose formula is this, C6H12O6. Now, let us calculate its molecular mass. As you see here, carbon atomic weight is 12. And the formula is Ma formula I'm going to use. So, atomic weight of carbon is 12. So, I'm going to write here into. Atomicity means the hanging number is 6. So, write here. So, 12 is the atomic weight of carbon. It will be given in your board exam in ICSE. So 12 is the atomic weight, and atomicity you can see out here is 6. So atomic weight into atomicity of the element called carbon. Now when you go to the next element, we need to write plus. Okay. Now let us go for hydrogen. Hydrogen atomic weight is how much? 1. into its atomicity. The hanging number is how much? 12. So atomic weight into atomicity. Now again, when you go to the another element, we write down the sign plus. Oxygen atomic weight is 16, you can see from here. Into atomicity, the hanging number for it is how much? 6. So what I have done here, to calculate molecular weight of any compound, you have to multiply atomic weight with atomicity. Atomic weight with atomicity. Atomic weight with atomicity. But when you go from one element to the other element, in between you have to write down the sign plus. Now, let us multiply these two, following Bodmas rule. First we multiply, then we add, isn't it? So if you multiply these two, you get 72. If you multiply these two, you get 12. If you multiply these two, you get 96. And if you add them all, it becomes 180, which is the molecular mass of glucose. Now I would like to show you the molecular mass of sucrose. Sucrose is actually cane sugar. Okay, so it's a formula of, simply you can say it's the formula of a sugar. So again, how to remember the formula? It looks so big numbers out here for you. Carbon is 12, hydrogen is 22, O is 11. Such a huge number. So when you have a tea, if you ask for a sugar, don't ask for sugar from now on, okay? Being a science student, you have to utilize it in day-to-day life. So do say it as C12, S22, O11 from now on. So can I have a cup of tea? Okay, sugar is less, so ask for 1 spoon of C12, S22, O11. So this is the formula of what? Sucrose. Now again, let us calculate its molecular weight. Carbon atomic weight, as you know, I have already shown you, it's 12. Atomicity is again 12. When you go to the next element, plus. Hydrogen atomic weight is 1, and its atomicity you can see out it is 22 in this case, plus oxygen atomic weight is 16, and atomicity for it is 11. Now let us multiply these all, following Bodmas rule. So 12 into 12 is 144. This will give you 22, and 16 into 11 is 176, if I am not wrong. Now if you add them, it will come 342, which is the molecular mass of sucrose. Now the very important acid, sulfuric acid. Okay, we call it by the name king of chemicals because we use in most of the reaction. So king of chemical means sulfuric acid, whose formula is H2SO4. Now we will calculate its molecular mass again. Hydrogen atomic weight is how much? 1, and atomicity is what? 2. When you go to the next element, again we write plus. Sulfur atomic weight, I have shown you out here, is 32, so write into how much is hanging. No number means how much is there? 1. When you go to the next element, again plus. Oxygen is 16. Into atomicity of it is how much? 4. Now again apply Bodmas rule, multiply these two, you get 2, multiply these two, you get 32, and if you multiply these two, you get 64, and if you add them all, it will come 98. So in this way, you can find the molecular weight of element compounds also. I have shown you only 3 out here, so by this you can find the molecular weight of other compounds also, provided you atomic mass will be given. Okay, in your board exam, atomic mass will be given, and you need to know the formula from where you come to know about atomicity, and multiplying those two, you get the molecular weight. But do remember, when you go from one element to another element, you have to write plus in between. Now we are going to learn about one important term again in chemistry. Okay, it has come in your board exam for several times, but students hesitate to remember it because they get confused. And that is, the terms are oxidation, reduction, oxidizing agent, reducing agent. So they have a phobia with these terms. I like to give you some help to remember these words in a very easy way. Okay? As you know, in lower classes, you know about oxidation, reduction. How you have learned? Oxidation means addition of oxygen or removal of hydrogen. And similarly, reduction means addition of hydrogen and removal of oxygen. And this concept will work in your board exam. But more than that, I'm going to give you a different definition of oxidation today. And let us see what is that. Do remember, oxidation, okay? To remember oxidation, you remember the word oil. O-I-L, oil. Now what is the benefit of remembering this word called oil? Okay, in oil, O stands for oxidation. I stands for increase in number. Actually, this is oxidation number for higher studies. For your standard, you just remember increase in number. And this L stands for loss of electrons. And loss we represent by the sign minus. Okay? So what is the full form of oil? O stands for oxidation, I stands for increase in number, which is actually an oxidation number, and L means loss of electron, represented by the sign minus. So remember oil, you remember about oxidation. Now what is reduction? Make it opposite. Here is reduction, decrease in the number. Here will be gain of electron, and the sign will be what? Plus. And the sign will be what? Plus. So that means if you remember oil, you remember about oxidation. Make it opposite, you remember about reduction. Okay, one more time. Oil, O means oxidation, increase in number, loss of electron, sign is minus. Now reduction means here will be reduction, here will be decrease in number, and here will be gain of electron, that is the sign will be plus. And do remember, the one who suffer what? Oxidation are reducing agent. The one who suffer oxidations are reducing agent. And the one who suffer reductions are oxidizing agent. Just opposite. Remember oil, you remember about oxidation. And those who suffer oxidations are reducing agent. Similarly, the opposite of oil will become the definition for reduction, and those who suffer reductions are oxidizing agent. Now I like to give you some sample here. Okay, now this is your sodium. Now is it an oxidizing agent, reducing agent? Will it suffer oxidation or reduction? No idea. Now see how we get the help with this concept called atomic number, base concept. Atomic number of sodium is 11, so the configuration will be 281. I have already said you. Since it has one electron in the outermost shell, so it is a metal. Being a good person, it loses electron. So how many it can lose? 1. And those who loses electron, they suffer oxidation. Suffer oxidation. And those who suffer oxidations are reducing agent. So from this example, you can say that sodium is an reducing agent. How? From the atomic number, I got the configuration. From configuration, I came to know it's a metal. Being a metal, it loses electron. And those who lose electron, they suffer oxidation. Okay? And those who suffer oxidations are reducing agent. Now, I'll give you another example for chlorine. Chlorine atomic number is 17. So, the configuration of it will be 287. Okay? It has 7 in the outermost shell, means it is non-metal. Being non-metal, I consider it as a bad person. So, they usually gain electron. Bad person gain electron, and those who gain electron, they suffer reduction. Those who gain electron, they suffer reduction, and those who suffer reductions are oxidizing agent. So do remember, from now on, most of the metal, they suffer oxidation, loss of electron, and they act as reducing agent. Non-metal, they suffer reduction by gaining electron, and they act as oxidizing agent. So remember, usually metals are reducing agent and non-metals are oxidizing agent. One question of ICSE in fill in the blanks was like this. Metals usually suffer dash, fill in the blanks, and act as dash. So metal usually suffer what? No, oxidation due to loss of electron, and act as dash means reducing agent. Now, to remember this, you remember the word milor. Now, what is the meaning of milor? Okay, milor. In the word milor, this M stands for metal, E means electron, L means loss, O means oxidation, and Re means reducing agent. So the full form of milor is like this. Metal, generally the electron they lose. As a result, they suffer oxidation and act as reducing agent. Okay? Now, how to remember for non-metal? Make it opposite then. Non-metal, electron they gain. As they gain electron, they suffer reduction. And since they suffer reduction, they act as oxidizing agent. Now, one question in your ICSE, the question was like this. Alkali metal are strong reducing agent. Alkali metal are strong reducing agent. You need to explain it. Now, how to answer this question? Forget about alkali, see the word metal. So, alkali metal is a metal. So, metal, usually they lose electron, you can see from here. As a result, they suffer what? Oxidation, and they act as reducing agent. So, do remember, metals, alkali metals, usually they lose electron and they suffer oxidation. As a result, they act as reducing agent. So, join the same terms, you get the answer for that question. Similarly, if I ask you, fluorine is a reducing agent. Fluorine is a oxidizing agent. Explain. Okay. In this question, how to go now? Now, first remember the atomic number of fluorine. Fluorine atomic number is 9. So, the configuration will be 2, 6. Sorry, 2,7. So having 7 electron in the outermost shell, it is a non-metal. Being non-metal, it gains electron from others. As it gains, it suffers reduction. As it loses, suffer oxidation, but chlorine gains electron and suffer reduction. As a result, it acts as oxidizing agent. So students, in my class of today's, I have explained you about basic concept of chemistry. Do remember the atomic numbers of the elements, which is going to help you in learn wrong. Then I have explained you about what is oxidizing agent and what is reducing agent and how to calculate molecular mass. So in my next class, I'm going to teach you about some other portion which is important for your syllabus, your entire syllabus. Okay? So see you, stay home, be safe. Thank you very much.